we're going to solve the LeetCode problem contains duplicates. So we are given an array with some numbers, and we have to return true if it has any number appearing more than once, or false if it doesn't. So the naive solution that we could go for is to just loop through the array, and for each number then check if it also appears in the array at a different index. So we start by looking at 1, and then we check all the values after it and see if we find a 1, and we do, and therefore we would return true because it contains a duplicate. And then for this one, we would start at 1, look at all the other values looking for a 1. We don't find 1, so then we go look at 2. We then check the values after it, and we don't see a 2. We then look at 3, look at the values after it. We don't see a 3, so we don't return true. And then we look at 4, and then also we don't find any values after it, and so we know that it doesn't have any duplicates. That's not a great solution because for each value of the array, we're going to then have to loop through the entire array, and then therefore that will give us a time complexity of big O n squared, although it will give us a constant space complexity. The solution we're going to go for is to use a hash set, which is going to store all the values that we've already seen. And for each value that we look at, we're going to check if it's already in the hash set. If it is, it means we've seen it. And if it's not, then we add it to the hash set and continue to the next value. This is much better because the set addition and checking if a value is in a hash set has a constant time complexity. So we'll have a set. Initially, it's going to be empty. And we'll look at the first value. We'll check if that value is in the set. It's not. Therefore, we haven't seen it before, so we'll add it to the set. We'll then look at 2. We'll see, is 2 inside of the set? It's not. Therefore, we can add the 2. Is 3 in there? It's not. Therefore, we can add it to the set. We then check if the 1 is in there. It is in there. Therefore, we return true because we found a duplicate. Now we'll go through this example. So if we create a set, we look at the 1, we check if it's in the set, it's not, so we add it. We check if the 2 is in the set, it's not, so we add it. We do the same with the 3 and the 4. And now we're at the end of the array, but we haven't returned anything, therefore we just return false at the end. So let's code that solution. We'll have a hash set called scene, and then for each value in nums, we'll check if it's in scene. So if n is in scene, we then just return true because it means we found a duplicate. Otherwise, we'll add it to the hash set. And then if at the end of this loop we don't actually end up returning anything, we can just return false. You might think that you could just do this with an array, so you could swap out the set with an array and then just do very similar things. And the code looks very similar, but it's actually going to perform much worse because this operation here, where you're checking if a value is inside of scene, it's going to actually have to loop through the entire array to check if that value is in that array, which is a lot less efficient and actually gives this a big O of n squared complexity. Two things you might have noticed is that in both of these cases, we have to loop through the entire array. That's why it has a big O of n complexity. But the operations where we're adding and checking if a value is in the set is constant. The other thing you might have noticed is that the set, if there are duplicates, is going to be slightly shorter than the initial array. So using that fact, we can actually just form this scene array and then use that to compare the different sizes of these data structures and then use that to know if there was a duplicate. So we can actually just one-shot this entire problem. We just do return length of the set of nums. This will basically return it, but without any of the duplicates. And if that length is different from the length of just nums, then it means that there were duplicates because the length changed. It means it removed some of the duplicates, and then it returns false if the lengths are the same because it means there were no duplicates. If you're finding this complicated, I highly recommend you look into sets and hash sets and understand how the data structure works. I wouldn't recommend going for this solution in an interview. It's much better to actually code it out, but definitely if this ever comes up in an interview, just explain both of these options.